Okay, so now we're working on chapter 8.3, the area of circles. So we're going to look at exponents and powers, which is something totally new. Then take it from there, area of circle, formulas, and calculations. Okay, so exponents. This is a very important part of knowing the area of a circle. So let's get to it. Now, when you have an exponent, this is what it would look like. You have, for example, this 2 to the fourth. Okay, and the fourth is that little tiny number that goes up in the air. So your exponent, that's what it's called, the exponent. Okay, what that means is you're going to multiply 2 4 times. 1, 2, 3, 4. So that actually gives you 16 because when you look at it, 2 times 2, that's 4. Multiplied by 2 again, that's 8. Multiply that by 2, that's 16. How many times did we multiply by 2? 1, 2, 3, 4. That's 2 to the fourth. Okay? So this little 2 here, that's the number that repeats. So here are some different words that we use. We have 5 to that 2, that's 5 squared. We have 4 to the 3. When it's to the 3, it's cubed. So think squared. You've already worked with squared numbers. If there's a 2 as the exponent, cubed would have the 3. Okay? So then that 5 squared would actually just be 5 multiplied twice. Go back. So 5 times 5, what does that give you? 25. 4 multiplied 3 times. 4 times 4 times 4. So you think, well, 4 times 4, that's 16. So those two gives you 16. And then 16 times 4, why? That gives you 64. All right. Okay, so there is a video on exponents that we're going to watch here.
Hello again, everyone, and welcome to this lesson where we are going to explore the basic concepts behind exponents. Now, as always with our lessons, we're going to start out by guiding our thinking with a question, and that question is, what is an exponent? But first, let's chill by the pool for a moment. Let's also consider the addition of a tropical drink, which would not be complete without a mini umbrella. What does this have to do with math? Well, exponents work like this. We have some number that's called our base value. That's like the actual drink in the glass. Exponent is like the little umbrella up at the top. So now we can extend our thinking to looking at some numbers. Imagine if we had 3 with a little 2 up at the top right-hand corner. This notation says that 3 is the base value and 2 is the exponent. We should also note that exponents are also called powers. So for this example, we could say 3 to the power of 2 or 3 raised to the power of 2. So now mathematically, what does 3 to the power of 2 even mean? So this is how it works. We always start off with the base value, in this case 3. And since it's being raised to a power of 2, we will be using the number 3 2 times. And anytime we work with exponents, our operation is going to be multiplication. So we're multiplying those 2 3's together. Another way to say it is 3 times 3, which we know equals 9. So 3 to the second power is equal to 3 times 3, which is equal to 9. And now we can extend this thinking. We know that 3 to the second power equals 3 times 3. We're multiplying 3 twice. 3 to the third power equals 3 times 3 times 3. We're multiplying 3 times. And, of course, 3 to the fourth power is going to equal 3 times 3 times 3 times 3, or 3 multiplied 4 times. So now we can stop and make a conclusive statement, and that statement is that an exponent tells you how many times the base value is multiplied by itself.
Okay, so now that we've had this examples of exponents, little introduction, we look at these examples. So you have 5 squared. That actually becomes 5 multiplied by 5, which is 5 times 5, 25. So 5 squared is actually 25. Then you have 9 cubed. 9 times 9 times 9. Okay, so you think, okay, 9 times 9 is 81. Then 81 times 9, well, you can do your scratch work for that. So you know this is 81. Oops. And then you're multiplying by 9 again. So what does that give you? That gives you 729 is 9 cubed. Okay, and then you have 4 to the power of 5. So same times the thing. 4 times 4 times 4 times 4. And that will give you your answer. You just multiply it. And if you have to do it each time, you're like, okay, 4 times 4, that's 16. And then you can carry on. That's what you need to do. 10 to the power of 1, well, that's 10. Anything to the power of 1 is just that number. Anything to the power of 1 is the base value. Okay, and then 8.1 squared. Okay, so that gives you all those examples. All right, so you can pause here to see before to figure out this one here and this one here. Okay, so your 4 times 4 times 4 times 4, 4 to the power, of 5. Missing one. Okay, so we have 4 times 4, that's 16. That's only 2. So you can even speed it up. You could even say, I'm going to group this, and I know this is going to be 16, so that actually becomes 16 times 16 times 4. Because you know this is going to have 2 of them here, 2 4s here, and then that's your 5th 4. So when you do your scratch work, using your calculator, 16 times 16 is 256. Multiplied by 4 gives you 1024. Okay, that's your final answer. And then 8.1 squared. So it's not 8.1 times 2. It's 8.1 times 8.1. That gives you 65 and 61 hundredths. Okay. Now let's look at the area of a circle. So area, it's the space inside the circle. Right here, this 13 meters, that's our radius. Because it starts at the center and it goes to one of the edges. Now, when we're looking at the area of a circle, this is the formula. A equals pi r squared. pi r squared. So not d squared, but r squared. So what if you're given the diameter? What if you're given the diameter? Then that just means you divide the diameter by 2 to get your radius. Okay? All right. So as per usual, you write down the formula, you fill in the values, and you calculate. And remember, it's area, so it needs to be squared. Squared, squared, squared. Okay, it needs to be squared. So another way of looking at that formula is A equals pi, 3.14, times r times r. Okay, it's not the same as 3.414 times radius times 2. This is wrong. No, that's not how you do it. This is what it actually means. Okay, let's look at a couple examples. So these are radius. Now, A equals pi r squared. So 3.14 multiplied by 10 times 10. Okay, not 10 times 2, 10 times 10. Because the radius is 10. Okay, so you have 3.14 times 10. That gives you 31.4 times another 10. So you can do it incrementally. 31.4 times another 10 is 314 centimeters squared, because it's area we're looking for. Okay, do the next one. Again, this is the radius. Radius is 5 centimeters. So A equals pi r squared. Next, 3.14 times 5 times 5. Okay, or even 3.14, 5 squared. Whichever one. Now, 3.14 multiplied by 25, because it's actually 5 times 5, correct? That gives us 78.5 centimeters squared. It's area, not circumference, squared. Okay, let's look at the next one. Okay, so now looking at this is actually the diameter. And if you remember, diameter is actually 2 times the radius. So I'd have to divide this by 2 to get this side. What's that? So d over 2 equals r. Diameter divided by 2 equals the radius, which is 6 divided by 2 equals 3. It's 3 centimeters. Okay, let's figure out the area then. Pi r squared. 3.14 multiplied by 3 squared, which is actually 3.14. If you were still a bit confused, 3 times 3. I just want you to see how it's done in each step. You can skip steps if you need to, but I want to see most of the work. And centimeters squared. Because again, it is area, not circumference, not the distance around. It's the area inside. Okay. Now your homework, pages 92 to 93, questions 2 to 9. Calculate, don't estimate. All right, Mathletics, you can work on area of circles 1. Okay, after that, we're going to just move on to the next unit, equations, expressions, and algebra, and we'll see how far we will get. Okay, remember, ask any questions, if you are having difficulties.